Now let's take a look at this question. Magnesium oxide is produced by heating magnesium, the metal, in the presence of oxygen as follows. So here's the balanced chemical reaction. In a certain reaction, 10 grams of oxygen was allowed to react with excess magnesium. Please note, this information, excess magnesium, tells you oxygen is the limiting reactant. So if it doesn't say here magnesium, one of the reactants is excess, so therefore you have to actually work on very first part. You have to work on finding the limiting reactant. But in this case, it already indirectly tells us that oxygen is the limiting reactant. Okay, that's good. We save some work. What is the percent yield of this reaction if 5.65 grams of magnesium oxide was isolated? Isolated in this case means, after the reaction, they collected this many and purified it, separated. So they got exactly 5.65 grams of magnesium oxide. As a matter of fact, this is the actual yield, in other words. Okay, so that's the actual yield. Now we know the molar mass of both oxygen molecule and magnesium oxide. Even though if those information are not given, the molar mass, you can obtain those information easily from a copy of periodic table. And here are the 4 choices. Now, whenever you see a question, of course, so you find out what you know. Okay, you know the mass of oxygen, and then, so you know the actual yield of the product, and you also know the oxygen is a limiting reactant. So then you can develop a plan of solving the problem, okay? So first, obviously, in order to find out the percent yield, we have to find out the theoretical yield first. The theoretical yield, you start with what you know. You cannot start with what you don't know, all right? What do we know? We know the grams or the mass of oxygen. We can convert from oxygen to the moles of oxygen using what as the conversion factor? Using the molar mass of oxygen as the conversion factor. On the second step, we are going to carry out the stoichiometry calculation, which means we need to use the mole ratio as a conversion factor, and the ratio should be the coefficients in this balanced equation. All right, so that way we can convert from moles of oxygen to moles of magnesium oxide. And then the last step in this first phase of the calculation is to convert from moles of magnesium oxide to grams of magnesium oxide, using what as the conversion factor? The molar mass of magnesium oxide. All right, so this way we should be able to obtain the theoretical yield. And the actual yield is already given, then we can just use this equation. Percent yield equals actual yield divided by the theoretical yield we calculated here. We will calculate that, then times 100%. All right, so developing plan or strategy is always important, especially for a little complicated questions like this, okay? So after you have the plan, after you know how to carry out the calculation, so this is what you do. You just do it. Start to solve the problem. Theoretical yield, okay, we start with grams of oxygen, have 10 grams of oxygen, all right? And then convert from oxygen, converting from, put that on bottom, converting to, put that on top, all right? So we are converting from grams of oxygen to moles of oxygen. So now you see we can cancel the grams of oxygen and grams of oxygen. So next, we are going to convert from moles of oxygen to the moles of magnesium oxide, all right? And the conversion factor is actually the coefficient ratio in this balance equation. We are converting from moles of oxygen, all right? Because here, after canceling the grams of oxygen, we just have the moles of oxygen left from that step. And now, so converting from moles of oxygen, put that on bottom. So we can cancel the moles of oxygen, you see, and the ratio is 2 magnesium oxide to 1 oxygen molecule, all right? So to 1, okay, 2 to 1. 2 moles of magnesium oxide to 1 mole of oxygen. Then we are going to convert from moles of magnesium oxide, converting from moles of magnesium oxide, put that on bottom as a denominator, to the grams of magnesium oxide using the molar mass, all right? So this way you see moles of oxygen, moles of magnesium oxide and moles of magnesium oxide can be cancelled. You see, I cancel the unit, moles of magnesium oxide, okay? And now, the answer from this time, 25.2 grams magnesium oxide, that's the theoretical yield, okay? So now, we are ready to calculate the percent yield. We just copy the equation from here, okay? The actual yield is 5.65 divided by the theoretical yield. We just calculated. Then times 100, that gives us 22.4%, which is choice A. So that's the correct answer for this question.